All right, hi everybody. Today I'm going to jump into chapter 2. I know we're going really fast, but a lot of this is review again, so here we go. Learning targets are on the screen. We're going to focus, we're going to just go in order. A lot of this stuff should be review, and then there's just going to be some stuff that's maybe a little new at the end of the lesson. Functions are relationships between x variables and y variables. And the important part is when you put in one x variable, you always get only one y output. For instance, this one right here, if I put in 3, I get out somewhere like 1.7-ish, but I could also get negative 1.7-ish. And so that, because I got two outputs, that means that this is not a function. Not a function. Whereas if I compare that with this one, if I put in 1, then I get out only one output, which is 1. So there's one output here. So this is a function, but this is not a function. So there's a comparison here. One way to tell is you can take a vertical line, any vertical line, and if the vertical line touches 2 places on the graph at a time, then it's not a function. And so all of these vertical lines that I just drew on this side, they work. There's only one output. All of these vertical lines that I drew over here hit 2 things. So that means that this is not a function and this is a function. 2 more vocabulary words for you. Domain is the set of input values that you're going to put in. This is the x values. And the range is the set of output values. So this is the y values. We'll get into that more later this year, but I have to introduce that vocabulary today. Okay, in function notation, we use this f of x thing, and we read it out loud, f of x. So f of x means there's a function named f, and the variable you put in is called x. So you can call this function right here, f of x, and this function right here is g of x. F of x and g of x are 2 different functions, but they both can be used at the same time because we have separate names for them. So that's kind of helpful. The other thing that I want to show you about is evaluating functions. So first I'm going to do f of 6. F of 6 is what happens when you put 6 in where the x's are. So I'm going to put a 6 everywhere I see an x. So 3 times 6 plus 2. 3 times 6 is 18. 18 plus 2 is 20. So f of 6 is 20. I'm going to do the exact same thing with g. This says evaluate what g of 9 is. So I'm going to put 9 in where I see x's. So g of 9 is 1/2 times 9 minus 6. So 1/2 of 9 is 4.5. So 4.5 minus 6 is negative 1.5. So then g of 9 is negative 1.5. Okay, so I have evaluated these functions for values of the variable, and I have already met learning target 2A, which is I'm telling you what value to put in for x, and you're going to give me the output. That's what I mean by find outputs or evaluate. Okay, so let's jump into what slope is. Slope is the letter m when we talk about, maybe you remember mx plus b, y equals mx plus b. Slope is the m. And so the m is the change in y divided by the change in x. Here is the normal slope formula that you will use. Remember that this is for the point x1 comma y1, and x2 comma y2. So if you have 2 points that are given to you, or you have 2 points on a graph, you can use this formula to find the slope of the line that goes through those 2 points. So here it is. Remember that our slope formula is m equals y2 minus y1 divided by x2 minus x1. Okay, so I'm going to label this as x2, y2, and I'm going to call this x1, y1. And then I'm going to take all of these and put them in where they belong, etc. Okay, so I will get x2 is 8 minus sorry, I made a mistake. y2 is 1 minus y1, which was 7, all divided by x2, which was 8, divided by x1, which was 0, or minus, excuse me. So I set this up and then I simplify. 1 minus 7 is negative 6. 8 minus 0 is 8. This fraction is my slope. M is negative 6 over 8. Or you could simplify that fraction and write negative 3/4. Okay, when you look at slopes, there are 4 different kinds of slopes. There's positive slopes, negative slopes, zero slopes, or undefined slopes. Zero slopes are straight across, undefined are straight up and down. Negative is decreasing from left to right, and positive is increasing from left to right. Okay, so the y-intercept is where the graph crosses the y-axis. So that's this spot right here. Y-intercept is 0, 7. Okay, we saw that our slope is negative 3/4 here. So I'm going to write my equation for this line in the form y equals mx plus b. B is the value when x is 0. So b is 7. M is negative 3/4, so y equals negative 3/4 plus 7. There's my line equation. This one I want to make it look like y equals mx plus b. So I need to solve for y. And that's why we practiced on Friday and Thursday solving for a variable. So we have to get y by itself. So what we need to do is we need to, okay, what do we got to do to get rid of this stuff? We got to add 4 x's to both sides. Remember, whatever you do to one side, you have to do to the other. I'm going to rewrite over here what I get left. So these two add up to 0. So I get 2y on this side equals 2 plus 4x. Now I need to divide both sides by 2 to get y by itself. Okay, so then I can do piece by piece. I get y equals 2 divided by 2 is 1. 2 divided by 2 is 1. And then 4x divided by 2 is 2x. What is y, or what is m and what is b? M is the slope and it's 2 because it's next to the x. B is 1. So my y-intercept is the point 0, 1, which is right there, and my slope is 2. So I need to go up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. Continue that all the way as far as you can on the graph. Just make sure that you do that. And then draw your line through those points, like that. Okay, point slope is another way of writing an equation for a line. M is still the same rise over run or slope. I'm going to use these 2 points right here to find the slope. So you can count 1, 2, 3, 4, 5 over 1, 2. So m is 5 over 2. If you don't believe me, you can go back and use the slope formula, but for now I'm going to move on from there. Then I'm also going to use this point right here. This point is the point 2, negative 7. Okay, so this is x1 and this is y1. So that's where I get these numbers. Now I have enough to write my equation. So y minus negative 7 equals 5 halves x minus 2. Now I want to put this into slope-intercept form in a second. This is point-slope form. I could also write this as y plus 7 equals 5 halves x minus 2. This should be review. We should have seen this before. If you're just like, oh man, I barely even remember any of this, you got to email me right away because we got to get this figured out. Okay. I do want to take a second here and I want to solve for y and combine like terms and simplify and turn this into slope-intercept form because I'm going to ask you to do that. So what I'm going to do is I'm going to take my 5 halves and distribute it here and here. So I get 5 halves x minus, okay, 2 times 5 halves is 5 equals y plus 7. And then I'm going to subtract 7 from both sides. So I get y equals 5 halves x minus 12. And there's your answer. You can check that you did this right because you can see that this line crosses the y-axis at x equals or at negative 12. And so that works. Okay, very similar. I have a point. This is x1, y1. And put in my slope is negative 4. So m is 4, negative 4. And then y1 and x1 are there. Okay. So let's quickly do this. Y minus negative 5 equals negative 4 x minus 4. Okay. Again, I'm going to distribute and simplify. So I'm going to take this negative 4, bring it through, and then combine all the like terms. Remember that your y minus negative 5 is the same as y plus 5 equals negative 4x plus 16. And then I'm going to add or subtract 5 from both sides. So then I get y equals negative 4x plus 11. There is your answer. Remember, I'm just going to y equals mx plus b because I'm an all-star at writing and making equations and lines for y equals mx plus b. Point slope's a little bit more challenging, but this is what I'm really happy with. So I want to just make sure that I have the skill to get from point slope to y equals mx plus b. Oh, I did that. Sorry. Yeah, so I'm going to skip this. Okay, let's write an equation for this graph. Slope is m equals negative 1/2. It's negative because it's decreasing from left to right. So let's see, do I even need to go to point slope? No, because I have my y-intercept. My y-intercept is the point 0, 1, and my slope is negative 1/2. So y equals negative 1/2 x plus 1. There I am, I'm done. Okay, now I have some information about 2 points, and I want to put a line through these points. First, I'm going to graph them. 5, 1 is this point right here, and 7, 9 is this point right here. 7, 9. Okay, so first I need to find the slope, then I need to write an equation. So what is the slope? Well, 9 minus 1 over 7 minus 5 is 8 over 2, or 4. So m is 4. What is a y1 or a y2? Well, I can use either one of the points, but for my purposes, I'm going to just use this one. So x1, y1 is the point 5, 1. Okay, so y minus 1 equals, slope is 4, x minus 5. Okay, again, I'm going to distribute and combine like terms, so then I get 4x minus 20 on this side equals y minus 1. Add 1. I get y equals 4x minus 19. There's my equation in slope-intercept form. Then I'm just going to draw my line through these points. There you go. Okay, so now we have met all of the objectives in Learning Target 2B. I'm going to switch over to my Chromebook to talk about the next part because we need a calculator.